I'll be going through each of these problems, but you can go ahead and check yours first and pause the video when you need to. Alright, so you just watch whatever you need to watch. You don't need to watch me do every problem. A secant is a line that hits 2 points on a circle. So this would be an example of a secant that hits 1, 2 spots. The secant is the entire line, where the chord is only the segment, right? Chord is a segment that hits 2 points on the circle. Arc LM, so there's only 2 letters there, so I know it's a minor arc, which means it's going to be less than half of the circle. So maybe we could say this arc right here is arc LM. Diameter JL, diameter would go through the center of the circle, JL. A tangent line just touches the circle, just at one point, one tangent point, and then if we needed to name that KS, we would have to put another point and mark those as K and S. Arc KML, that's 3 letters, so that's telling me that it's a major arc. So it's going to start at K, go around the circle at some point, it's going to pass through M, and then it's going to go more than halfway around the circle and finally end at L, so that would be major arc KML. Radius KP, you can go to any point on the circle, we'll call it K. That would be our radius. They're the same length all the way around. And intersecting tangent and secant. So I could draw a secant line, and then I would need to draw a tangent line that intersects that. Lovely. Number 2. Orbiting 180 miles. So this little distance right here is 180 miles. What is the distance d from the shuttle to the horizon? The radius is 4,000. So from here to here is 4,000, and also from here to here is 4,000. And we know that since that's a tangent line, this is going to be a right angle. So we're going to Pythagorean Theorem. So this is the hypotenuse, yeah? So 4,000 squared plus d squared equals, how much is that all together? 4,180 squared. So then we're going to square both sides. Calculator this one. Subtract. Don't forget to take a square root, and then we're going to round to the nearest tenth. And so 1,213 miles is the distance to the horizon. On number 3, I would suggest that either you have scratch paper or you write on the printout, but you need to figure out all of those angles first is the easiest way to do this, I think. So since I know that this angle is a 70, this arc is a 70. And this angle is a 30, so this arc is 30 degrees. And then if we look for diameters, that's going to help us. That means that this half of the circle would be 180. So far I've got 70 plus 30 already. That's 100. So this arc would have to be 80 to make that 180 total. Look for some vertical angles. Do you see how the 70 has a vertical angle over here? So vertical angle is congruent. That would have to be a 70. And then we could either do more vertical angles or think of another semicircle on this side. So if that's 70, this would have to be 180 minus 70, 110. That's what I like to do first, is figure out all of my arcs and just write them down. And then when they ask me for the measures of the arcs, I'll kind of have the answers over there. So arc MN was that minor arc, that 70 degree we figured out first. NQR. So we go from N around the circle through Q and then to R. That's actually a semicircle, right? half of a circle is 180. QR, the minor arc, QR, that was our vertical angle, so 70 again. QMR, so I'm not going to go from Q straight to M, this is an arc, so I have to go the curvy way. Q through M and then to R, so I would have to be going this way, right? Q through M and then to R, so that would be 30 plus 80 plus 70 plus 110, 290. Oops. Another way you could do that, did you notice that QMR is everything except for that 70? You could do 360 minus 70 if that's easier. I've made a mess here. PRN, PRN. So another major arc, we're going all the way around the circle except for that 80 degrees. So you could do 360 minus 80, or you could just take the 30 plus the 70 plus the 110 plus the 70, and that comes out to 280. This one we haven't practiced as much. Given OQ equals 7. OQ equals 7. That's the radius, yeah? Find the length of MP. So you would need to know your arc length formula. And it's just the measure of the arc over 360, sort of a fraction of the total circumference. So 2 pi r, or you could use pi d. So in this case, it's the measure of the arc. What are we finding? Oh, MP. M to P. Is that 150 degrees from M to P? 150 over 360 times 2 pi 7. And just type that in, rounding 18.3 to the nearest tenth. All right, onto these nice algebra ones. This one is 2 secant lines. Don't let it throw you if they have the entire secant line drawn. So do you remember the formula here? It's outside times whole equals outside times whole. So here we've got the outside is 3 times this whole thing would be 3 plus x, or x plus 3, equals outside times this whole thing, 7 plus 4. So most of you like to distribute, I think. Subtract the 9, divide by 3. So 11.6 repeating, but if we had to round to the nearest tenth, that would be 11.7, right? Okay, the next one, 2 chords that intersect. So I've got 1, 2, 3, 4 little chunks. And the way that the setup works is I'm going to take this one times this one equals this one times this one. Great. And, you know, don't trust your picture too much, but I think that seems reasonable that that would be 12. Again, I shouldn't probably trust my picture. All right, this one looks like we have a tangent segment and a secant line, part of it anyway. I like to use the same idea, outside times whole equals outside times whole. So for this one, it would be outside times this whole thing is 10. And for the tangent, the outside is x, but the whole thing is also x because it never goes inside. Outside times whole equals outside times whole. Square root of 60 is about 7.7. This last one was a bugger, wasn't it? So if you got the setup, I'm happy. Did you get the outside times whole equals outside, and this whole thing would be 16? If you got that, you're fine. The rest of this is just sort of reviewing some algebra, how to solve a quadratic equation, which is good to remember. You're going to have to know it in the fall anyway, right? So once we get to here, we notice that we have an x squared and an x, so we're not going to be able to just straight up solve for x. This is a quadratic equation. The way that we solve those usually is by setting them equal to 0. Now, if I could factor that, I would, but I can't, so I'm going to use the quadratic formula, where a is 1, b is 10, and c is negative 128. Do you remember the quadratic formula? Again, you wouldn't need to do this on the quiz today, just a good review of some math. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you manage to type that in correctly, you should get 1 answer when you do the plus and 1 when you do the minus. And the first one I got was 7.4, and the second one negative 17.4. Both of those are answers to that quadratic equation. Only one of them makes sense for our geometry, though, the positive one. So 7.4 would be the length of this x. So that was fun. What I want you to get out of that is, can you set that up? If you can set that up, you'll be fine. And on the questions I ask you, I'm going to have the x positioned differently, so you won't have to come to the quadratic formula. All right, before you start the quiz, make sure that you email me with any questions, because I want you to do your own honest work once you start. Thanks, guys.